Today, we are going to be learning about partial fractions. The method of partial fractions is a procedure for decomposing a rational function into simpler rational functions to which you can apply the basic integration formulas. The method of partial fractions was introduced by John Bernoulli, a Swiss mathematician who was instrumental in the early development of calculus. John Bernoulli was a professor at the University of Basel and taught many outstanding students, the most famous of whom was Leonhard Euler. The method of partial fractions is actually pretty simple. You can take the integral of 3x plus 11 over x squared minus x minus 6 dx. You then factor out the denominator and make it equal to a over the first binomial plus b over the second binomial. Now our goal is to find a and b. Now the next step is to cross multiply the right side. So you will have a times x plus 2 plus b times x minus 3 all over x minus 3 times x plus 2. So now is the time when we find a and b. In order to find a or b, you have to set the numerator of the left side equal to the numerator of the right side. First, we are going to be finding b. In order to find b, we have to get a to be multiplied by 0, and to do that, x would have to equal negative 2. So when we plug negative 2 into all the x's, we have 3 times negative 2 plus 11 equals a times negative 2 plus 2 plus b times negative 2 minus 3, which cancels out the 2's, making it a times 0, so you're able to solve for b. When you do the basic algebra, we find that b equals negative 1. So now in order to find a, we have to get it so b is multiplied by 0 so it cancels out. And to do this, x will have to be equal to 3. So we have 3 times 3 plus 11 equals a times 3. We have negative 3, but it's just supposed to be 3, plus 2 plus b times 3 minus 3. After doing basic algebra, we find that a equals 4. So now we're able to solve the integral. We have the original integral, 3x plus 11 over x squared minus x minus 6 dx, equal to the partial fraction, and this is also where we plug in the a and the b, 4 over x minus 3 minus 1 over x plus 2 dx. So now whenever you do the integration, you get 4ln absolute value of x minus 3 minus ln the absolute value of x plus 2 plus c. Now let's move on to another sample problem. We have the integral of 8x minus 17 over x squared plus x minus 12 dx. We factor the denominator and then set it equal to a over the first binomial plus b over the second binomial. And just like before, in the next 3 steps, our goal is to find a and b. In the next step, you leave the left side alone, and on the right side, you cross multiply and find a common denominator. This will give you a times x plus 4 plus b times x minus 3 all over x minus 3 times x plus 4. Now we set the numerator of the left side equal to the numerator on the right side. We have 8x minus 17 equals a times x plus 4 plus b times x minus 3. So in order to find b, x is going to equal negative 4, and in order to find a, x is going to equal 3. Now we plug in the x's to find a and b. First we're going to find b. So we have 8 times negative 4 minus 17 equals a times negative 4 plus b times negative 4 minus 3. After doing basic algebra, we find that b is equal to negative 7. Now it's time to find a. So now we plug 3 into all of the x's, and we have 8 times 3 minus 17 equals a times 3 plus 4 plus b times 3 minus 3. The 3's cancel out, and we find that a is equal to 1. So now, like before, since we have a and b, we're able to solve the integral. We have the original integral 8x minus 17 over x squared plus x minus 12 dx is equal to the integral of the partial fraction 1 over x minus 3 plus 7 over x plus 4 dx. Now we're able to integrate, and we find that the integral is equal to ln, absolute value of x minus 3, plus 7 ln, absolute value of x plus 4, plus c. And that is how you do partial fractions of integrals. Thank you guys for watching.